This is video 7D for the Year 8 Mathematics course. In this video we're going to be covering the theory behind algebraic flowcharts under the topic of equations. Specifically, we're going to explore how to build up an algebraic expression, how to undo an algebraic expression, the relationship between the build-up operations and the undo operations, and then we're going to cover some example questions. In our last video, we introduced this idea of inverse operations, and even more so, we saw how we can actually use them to solve algebraic equations. However, in this last video, we really only focused on very simple equations just to get used to the idea of inverse operations. Now, the reason why we did this as well is because when we're dealing with more complicated equations, we have to be very careful with how we use the ideas of inverse operations and maintaining balance in order to rearrange the equation and get the variable all by itself. In this video, we're going to be focusing on something called algebraic flowcharts, which are effectively a way for us to understand how we build up and undo algebraic expressions. Alrighty, now in order to introduce algebraic flowcharts, we're going to consider a very simple algebraic expression. Let's consider 2x plus 1. Now, the idea of building up to an expression effectively means that we're going to start with the variable that we have, in this case here x, and we're going to examine what individual operations we need to take and in what order to arrive us at this expression. So, let's start off with the variable x. Now, if we consider the expression 2x plus 1, the first thing that we're actually going to do here is we're going to double it. So we're going to multiply it by 2. What does this then give us? 2 multiplied by x results in 2x. So this part here, good to go. What we now want is we also want this plus 1. This is very straightforward. All we need to do here is we then just need to add 1 to this, which results us in 2x plus 1. So we can see here that what this build-up flowchart has given us is it's given us a nice sequence of events of how we get from the lone variable x all the way up to our expression, specifically detailing the individual operations and all the midpoints that we have to take to go from the beginning to the end. Now, on the contrary, what we're going to look at now is starting with the expression 2x plus 1 and how we go down to just x. So, in this case, if we consider starting with the expression 2x plus 1. Then, if we want to try and get this x all by itself, the first thing that I might do is get rid of this plus 1. What's the inverse of plus 1? It's, of course, minus 1. So if we subtract 1 from this, then it's going to cancel with that plus 1, which then just leaves us with the 2x. And now again, we want to try and get this x all by itself, but we've got this multiplication of 2. What's the inverse operation of multiplying by 2? It's, of course, dividing by 2. So this division by 2 is going to cancel with that multiplication of 2, which then just leaves us with x. Now, I want you to study the build up and the undo flowcharts very, very carefully, paying particular attention to these four operations, because hopefully you should notice some similarities going on. Specifically, we've got a times by 2 and a divide by 2. These, of course, are inverse operations. Similarly, we've got a +1 and a -1, which again are inverse operations. But what else do we notice? We've done these inverse operations in the reverse order. So with the build-up flowchart, we started with the multiplication of 2 and then we added the 1. With the undo flowchart, we started by minusing 1 and then we divided by 2. So what we notice here is that the undo operations are the inverse of the build-up operations, but in reverse order. So this is really critical for us because what this here means is that if we know how to build up to an expression, in other words, we start with a variable and then we perform certain operations to get to the final expression, then we immediately know how we can undo the expression to get back to the variable. And it turns out that it's these undo operations that allow us to solve the corresponding equation. However, we'll leave the actual solving of equations part for our next video. For now, we're just going to purely practice developing build up and undo flowcharts. Alrighty, so the first example that we're going to consider here is 3x plus 5. So let's first of all draw up a build up flowchart. So we need to start off with the variable x. Then if we have a look at what we've got, we're multiplying the x by 3. So let's make that our first priority. So x by 3 gives us 3x. And then we've got an addition of 5. So let's add 5 to this, which then gives us 3x plus 5. So that there is our build up flowchart. If we now want to create our undo flowchart, we're going to start off with the final expression of 3x plus 5. And we're just going to do the inverse operations in the reverse order. So we're going to do first of all the inverse operation of plus 5, which is minus 5. That will then result us with 3x, and then we'll do the inverse operation of multiplying by 3, which is of course dividing by 3. This then arrives us back at the variable x. The second expression that we're going to do is 10 minus 2x. Now this one here you have to be pretty careful with because it's a little bit deceptive in how it looks. The best way I can go about showing you how to actually do this one properly is by switching the positions of these two terms. So in other words, we're going to instead write this as negative 2x plus 10. So if we start off with the variable x, we notice that we've got negative 2 multiplied by x. So we're going to perform a multiplication of negative 2, which gives us that negative 2x. And then we've got this addition of 10. So we're just going to then write plus 10, which arrives us at negative 2x plus 10. So that there is our build up flowchart. Now, if we want to create the undo flowchart, we're going to start off with the final expression, which is negative 2x plus 10. And now we're just going to do the inverse operations of the build up flowchart, but in the reverse order. So first things first, we've got the inverse operation of plus 10, which is minus 10. That arrives us at negative 2x. And then we'll do the inverse of multiplying by negative 2, which is dividing by negative 2. Dividing negative 2x by negative 2 will arrive us back at x. And then the final example that we're going to consider today is the expression 8x minus 7 all divided by 2. So this one here is a little bit tricky because we've actually got 3 different things to consider, but let's just take it one step at a time. So when we're creating our build up flowchart, of course, we're just going to start with the x, and then we've got a multiplication by 8. So we'll do times by 8. 8 by x gives us 8x, and then we've got this subtraction of 7, so we'll just write take 7, which arrives at 8x take 7. And then the entire thing is being divided by 2. So only now are we going to impact the division by 2, which gives us 8x take 7 all divided by 2. And now if we want to create our undo flowchart, we'll start off with the expression of 8x take 7 over 2, and then we're going to perform the inverse operations of the build-up flowchart, but in the reverse order. So let's start off with this division of 2. The inverse of this is multiplying by 2. Multiplying all this by 2 gives us 8x take 7. Then we'll do the inverse of this minus 7, which is plus 7. Doing this, we get 8x, and then we'll do the inverse of timesing by 8, which gives us dividing by 8. And then this arrives as simply back at the variable x. Now, before we finish up this video, the last thing I want to quickly make mention of here is how important it is to make sure that you're doing these operations the right order. Because if you do not, you're going to get a very, very incorrect expression than what you're expecting. The really key thing to understand here, and this is always the idea that I used to try and use when I was learning this stuff, was to start with the operations that are most closely attached to the variable. So what you'll notice I did in these first two examples here is that if you notice, in both of these situations, we have a number directly attached to the x. In the first one, it was 3, and in the second one, it was -2. So we performed these multiplications first, and then we just had some additional number attached as well. In the first case, it was +5. In the second case, it was +10. So you always start closest to the x, and then you build your way outwards. And I'm sure if you look at this third example as well, you can see something very similar going on as well. The closest thing to the x in this case is this 8, so we times by 8 first. Then we had this -7, so we did that second. And then the furthest operation away from the x, and the thing that actually impacted the entirety of this numerator, was this division by 2. So that was then the last operation that we did. So again, cannot emphasize this enough. Start with the closest operations to the variable itself, and then build your way outwards. This very much will come down to practice as well. I'm not going to say that this process is the easiest thing in the entire world to learn, but once you get the hang of it and you practice this stuff enough times, it does become a whole lot easier. Alrighty, let's summarize what we've learnt today. So in this video, we looked into algebraic flowcharts. Build-up flowcharts are used to display the evolution from a lone variable to an expression using mathematical operations. Undo flowcharts are used to display the devolution from an expression to a lone variable. We explored how the undo operations are the inverse of the build-up operations in the reverse order. These undo operations will be used in the future to solve algebraic equations. Finally, we drew some build-up and undo flowcharts for some mathematical expressions. And that's it for now. See you in the next video.